Here we are with calculations on solubility of soluble salts. Calculation on solubility of soluble salts. I look at three examples, the three examples we have in our books. The first question there is saying 350 centimeters cubed of water was saturated by 157.5 grams of potassium nitrate at 30 degrees Celsius. Calculate the solubility of potassium nitrate at 30 degrees Celsius. This is our question here. First of all, let's interpret the question. The question says that we have 350 centimeters cubed of water being saturated with those grams of potassium nitrate at 30 degrees Celsius. Okay? And from the definition of solubility, we said it's the mass of a solute that can saturate 100 grams, not 1,000, of a solvent at a given temperature, which is now the 30 degrees Celsius. Okay? So we need to convert this mass of this volume of water, first of all, to mass. So we shall say mass of water is equal to the volume times density of water. Density of water is known to be 1 gram per cubic centimeter. So that would be 50 times 1, which gives me 350 now grams. Then we shall simply say that 350 grams of water are saturated by 157.5 grams of potassium nitrate. At what temperature? At 30 degrees Celsius. How about 1,000 grams of water? I don't know why I'm so in love with 1,000. So beta should be 100. So 100 grams of water are saturated by, you write those same words, 100 times 157.5 cross multiply over 350. So from this, our answer will be 45 grams, give the units, per 100 grams of water at 30 degrees Celsius. That will be our solubility of potassium nitrate at that given temperature. So that's how we calculate solubility of a soluble salt. We have another question about this. That's very clear. The other question is now my part B. It says the solution in A was cooled. Solution in A was cooled at 15 degrees Celsius to 15 degrees Celsius. Remember, the initial temperature was 30. We are now cooling it to 15 degrees Celsius. And remember, on cooling, Remember, in our graphs for application of solubility curves, we saw that cooling a solution crystallizes a salt. And that's how we were able in our previous discussion to separate potassium chlorate from potassium chloride due to its low solubility at lower temperatures. So we are now asked to calculate the mass of potassium nitrate crystallized if solubility at 15 degrees Celsius is 25.0 grams per 100 grams. We are putting the solution. We want to get the mass of potassium nitrate crystallized. So at this point, we begin from the solubility we already know, which we have calculated in our previous part, this one here. Okay. We begin from this solubility which we have. We are going to use this solubility which I have calculated, but here we are given the solubility at that temperature 15. Yeah, I think that's where we should begin from and say that at 15 degrees Celsius, 100 grams of water are saturated by 25.0 grams of potassium nitrate. Now, how about the water of the solution? The solution in A was 350 centimeters cubed of water, if you're recalling. It's 350. It's what we are cooling. So we want to convert this solubility to the one we want to determine how much potassium nitrate would saturate the same volume of water, but at 15, not the 30. That's what we are aiming at first. So how about the 350 grams of water? This one is saturated by 350 times 25 out of 100. When you press your calculator, I see this one giving you 87.5. Gives you 87.5 grams of potassium nitrate. So this is the mass of potassium nitrate that will be available in solution at 15 degrees Celsius. Now, to get the mass that is crystallized, we get the original mass of potassium nitrate in 350 cc's at 30 minus the mass of potassium nitrate in 350 cc's at 15. Are we together? Are you getting me?
Yes, teacher.
So therefore, mass crystallized will be equal to the original mass which we had, which is 157.5, minus mass which we are having now, which is 87.5. When you subtract here, I think you're going to get 70 grams. That will be the mass of potassium nitrate that was crystallized on cooling. I'm doing a second example here. That second example says we have 60 grams of a saturated solution of a soluble salt said have 60 grams of saturated solution of a soluble salt Z that gave or that gives 17.75 grams of Z at 50 degrees Celsius. Then we are asked to calculate solubility at 50 degrees Celsius. This question is very simple if you know the definition of solubility. If you don't know the definition of solubility, then it becomes hard for you. Let's interpret the question. We are saying we have 60 grams of a saturated solution. A saturated solution means a solution now of Z plus water. That means in these 60 grams, we have mass of Z and mass of water together. On cooling, we are having 17.75 grams of Z at the same temperature, 50. Meaning we can know the mass of water in this solution. What will be the mass of water that evaporated on crystallization? That is 60 minus 17.75. So that gives me, if you look at this, it will be 42.25 grams of water. After knowing the mass of water that was saturated, so this was the mass of water that was saturated, we can now calculate our solubility in 1 to 2 steps. We shall say 42.25 grams of water is saturated by which mass of solute? 17.75 grams of solute at 50 degrees Celsius. How about 100 grams of water? So 100 grams of water is saturated by 100 cross multiply 17.75 out of 42.25 grams. So this gives me my answer as 42 grams per 100 grams of water. I hope that's very clear also. These are concepts that are ignored by most of the literature, but very important and part of your syllabus. You never know what may happen. At any one point, somebody can set for you a question about them. Now, our last example about solubility is going to be in terms of moles. And that is question 3. Question 3 says the solubility of potassium chlorate 5 in 60 grams of the solubility of potassium chlorate is 60 grams per 100 grams of water. At which temperature? At 100 degrees Celsius. Then calculate the number of moles of potassium chlorate that can saturate 150 grams of water at the same temperature, that can saturate 150 grams of water at the same temperature. So the key point in this question is that the only difference between it and the first and second example is that for it wants us to get number of moles. So should first of all calculate the mass, and after getting the mass, convert that mass to moles using the RFM of potassium chlorate 5. Let's begin and see. We are told the solubility of potassium chlorate is 60 grams per 100 grams of water. That's where we begin from at 100. So we shall say 100 grams of water saturated by 60 grams of potassium chlorate. Then we ask ourselves, how about the 150 now, the question that is talking of? So the 150, write the same word, is saturated by, let's multiply 150 times 60 over 100. This will give me which answer? It gives me 90 grams of potassium chlorate. So this mass is what you convert to moles that the question wants, and say now molar mass of potassium chlorate 5. You know potassium is 39, chlorine is 35.5, oxygen is 3 times 16. The whole of this will give you 122.5 grams. So moles will be the mass, which is this 190 over RFM. This will give us 0.735 moles. So that's all about calculations on solubility. Prior to the questions about plotting and interpreting solubility curves that are sent to you within your books. I think everything is clear, members. Is there any question that you would like us to go through? Raymond, is everything fine?
Teacher,
Yes, please.
on number, the question is about the curves on number Roman 4.
Yes.
How would we obtain the two